All right, guys. So in section 6.5, we are going to have four different parts to this section. So there's a lot of stuff going on in here. So we're going to work on this section for this week and next week. So there's four different parts to this. Like I said, there's just a lot of stuff in here. So for today, what we're going to work on is the rational root theorem. We'll work on this a couple different times. So this, what we're starting off here is listing integer factors. This is a main part in what we're going to be able to do, or what you're going to need to be able to do in your in just in this whole process. So just listing the integer factors. So like for 12, just some integer factors, just numbers that we can multiply to get 12. So like 1 times 12 gives you 12, 2 times 6, 3 times 4. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. You don't have to list 6 twice because it's already listed there. And then 48 is listed there. I'm not going to read all those off. And again, like I said, that's one of the main things that you need to be able to do. But also something that you need to remember is that this says integer factors. So integers also includes the negative numbers, which I did not include here in these lists. But you could also get 12 by multiplying -1 times -12, or -2 times -6, -3 times -4, which is another thing you want to remember. So in the rest, this is just kind of like your fancy math terms here. You don't really need to worry about that. But what you need to remember here is that this is the rational root theorem. You do need to remember what a rational number is. And this is basically any number that can be written as a fraction. A fraction meaning like an integer over an integer. So no decimals over decimals or radicals, so no square roots. This will not get you any kind of square root answers. This just gets you fractions for your answers. So when we are doing, we're going to be focusing on synthetic division here a lot. And when you're doing synthetic division, just remember when we know it's the binomial is a root, it's when we get a remainder of 0. So that's another thing we have to remember from previous sections. So now we're going to jump into an example. So this is basically what we're doing here is when we find a root, when we're using this theorem, this is basically like we've done everything when we have an x squared as our highest power. We can use factoring, we can use completing the square, or we can use the quadratic formula. So the rational root theorem is what we use when we have higher powers. And this is something that we can use to kind of drop that power down to an x squared that will allow us to use the quadratic formula. So basically what we want to do here is we want to take the integer factors of the last number and divide them by the integer factors of the first number. And then when we do that, we end up with some kind of fraction that we can work with our rational root theorem and see if it will work to give us a remainder of 0. All right, so what we're going to do is we're going to start with the last number, so -3. So we want two numbers that will multiply to give us -3. So we actually only have two numbers here. So it's going to be the plus or minus 1 and then plus or minus 3. So 1 times 3, oops. And then this is going to be divided by the first number, which this number right here is just a 1. So it's just going to be 1 times 1, so plus or minus 1. All right, so then when we divide them, 1 over 1 gives us plus or minus 1, and then 3 over 1 gives us plus or minus 3. Okay, so this basically gives us four different integers: 1, -1, 3, and -3. All right, so we have four different options that we need to try. Now, we don't have to try all of them. We just have to try it until one works. And once one of them works, then we know it's going to work. Okay, and once it works, then once we get a remainder of 0, it'll drop it down to an x squared, and then we can use our quadratic formula to get our other roots. Okay, because it does say find all the rational roots. So well, once we get a rational root, we can kind of look at it and see if we know the other ones are going to be rational or irrational. So, so we want to see which of these will actually give us a 0 for the remainder. So what we're going to do is we're just going to go back to synthetic division now, and we're going to see which of these will give us a 0. All right, so we're going to take our, let's just start with 1. So we're going to say, we're going to take 1, we're going to put it on our shelf. Actually, let me use a different color so this is not, I don't want it to all run together here. So we're going to say 1, and then all of our integers, so 1, 1, -3, -3. And I'm going to bring the, let me see where I'm at here. Got my line here. I'm going to bring that 1, this one right here, we'll bring that down. So 1, multiply it, 1 times 1 is 1. Bring that down here, 1. So add those together, 1 plus 1 is 2. Multiply it, 2 times 1 is 2, so we're going to bring that over here. -3 times, or -3 plus 2, -1 times 1. Is this 1? -3. Come on. -3 plus 1 is -2. We did not get a remainder of 0, so therefore 1 did not work. All right, so basically I can just scrap this whole thing now. All right, next one, -1. 1, 1, -3, -3. Bring down the 1 times -1, -1. 1 plus -1 is 0. Times -1 is 0. -3 plus 0 is -3. Times -1 is 3. -3 plus 3 is 0. So we are good there, right? We got a remainder of 0. That means that -1 is a rational root, okay? So we know that x equals -1 is one of our rational roots. Now this down here would be x squared plus 0x, we don't need that, minus 3 equals 0. Okay, now this one here will not give us a rational root. This will give us an irrational root, because if we go through, if we add 3 to the other side, this would be x squared equals 3, and we take our square root of both sides, we would have x equals square root of 3. That is not rational, that's irrational. All right, so this right here is our only rational root. If you come back up to the directions, this says find all the rational roots. X equals -1 is the only rational root that we got here, okay? So that is the only answer. X equals -1 is the only one that gave us a rational root. So we are finished with that problem, okay? And again, feel free to pause, rewind, and do anything there to clarify any parts there. I'm going to go ahead and jump on to the next example here. And again, I would suggest that you pause, try the problem, come back, and see how you do with this one. We're going to have a couple more roots to try on this one, just because 15 has more integer factors. So I would suggest that you pause it, give it a try, come back and see what you get. So again, we got to start with 15. Well, 15 has plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. And again, this is all being divided by the integer factors of the first number, which the first number is just a 1. So plus or minus 1. Okay, so then again, we're going to divide these, which is just going to be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. All right, now, again, this time we have 8 numbers. There's +1, -1, +3, -3, +5, -5, +15, and -15. So there are 8 different numbers that we could potentially have to try. Now, you could jump around and you might happen to guess it on your first try, okay? You could just keep jumping around and see, you might be able to guess, but a lot of times that's going to be, I mean, unless you happen to guess correctly on the first try, that's not going to be the best way to do it. The best way is just to go 1, -1, 3, -3, 5, -5, and then 15 and -15. That's the best way to do it. So that's the way I'm going to attack these, is just by going in order. All right, so I'm going to start with 1, and so 1, 1, negative 17, and 15. And again, this is why we're doing the synthetic division, just because it's so much faster to do the synthetic division than to do the long division. We can jump through these pretty quickly just by using this, so that's why I'm doing it this way. So 1 times 1 gives us 1. Add these together, we get 2. 2 times 1 is 2, and actually you can see here in a matter of one attempt, we're going to end up negative 15 times 1 is negative 15. We got it on the first try. All right, we got a remainder of 0. Now, if you would have went through and tried that by just randomly guessing, and you would have, you might have guessed, because I think one of the other ones does end up working here. Actually, 2 of the other ones do. You might have guessed it on one of the other ones, but we got it on the first try here. So we have our list. If we're making a list over here, x equals 1 is one of our rational roots. So that one does work. But now look down here. We want to see, what do we have here? Well, this is x squared plus 2x minus 15. Okay. And this is a remainder of 0, but this is still an equation, right? It's still equal to 0. So equals 0. Now that's not equals 0 because of this 0 here. It's equal to 0 because of the equation up here is equal to 0. Now we want to see, again, you could factor, you could quadratic equation, whatever. But this one right here, if we look at this, this one does factor nicely. This is an x plus 5 and an x minus 3. I don't know why I switched colors there randomly. Go back to my green. Not that it matters, but x minus 3, right, equals 0. So I'm sorry, 5 times negative 3 is negative 15. 5 minus 3 gives you 2. So that's that would factor nicely. So yeah, if you would have randomly chose a negative 5 to start with or a positive 3, you would have guessed correctly that those would work also. So this one over here, if we have x plus 5 equals 0 or x minus 3 equals 0, I have no idea why this is randomly changing colors like that. That's kind of strange that it's doing that. But whatever, we'll just roll with it. Equals 0. There we go. We'll subtract 5, so we end up with x equals negative 5. Over here, add 3, x equals 3. So we end up with 3 rational roots here. And again, if you could have done synthetic division with any one of those 3 and still ended up with a correct answer, and you would have just ended up with different finishes to the problem, but they still would have all given you the same answer. So x equals negative 5 and x equals positive 3. These are your 3 rational roots. And again, it's very important that you finish out the problem. You don't want to just find one of them and then say, all right, I'm good, I'm done. You have to make sure you finish the problem. It does say to find all rational roots, right? Find all the rational roots. It doesn't say just find one. Find all rational roots of the problem. So there's all 3. That's it for that problem. Number 3. Now this one's a little bit different because we do have a number here in front of our x cubed, but we're going to start it off the same way. We're going to say, all right, last number is a 1, so plus or minus 1. Now that's our only factor there, but now our first number is a 2, so that's a plus or minus 1, plus or minus 2, because we have 2 numbers that will multiply to give us our first number. So now when we're dividing these, we have 1 over 1, so plus or minus 1, and then 1 over 2 is a plus or minus 1/2. I started to write a 2 there, so let me fix that. Plus or minus 1/2. All right, so now when we are doing our synthetic division, we got to start with 1, and then negative 1, 1/2, and then negative 1/2. Okay, so those are the ones we're going to start with. Now, I know that one of the answers is a 1/2 or a negative 1/2. I don't remember exactly which one it is. So I'm going to start with 1/2 just for the sake of time. And then So I'm going to do 1/2 and then -1/2. I know it's one of the 1/2s, so I'm going to start with one of those. All right, so I'm going to start with positive 1/2. And we got 2, -1, 2, -1. All right. So I'm going to bring down the 2. So 1/2 times 2 is 1. -1 plus 1 is 0. Times 1/2 is 0. Add those together, you get 2. 2 times 1/2 is 1. Guessed it right on that one. -1 plus 1 is 0. All right, so I have a remainder of 0. That means one of my rational roots here, what I just tried, is 1/2. And again, rational just means fraction. No square roots. No decimals that don't end. Well, I mean, I guess they could be decimals that don't end, like 0.3 repeating would be a fraction of 1/3. But anyway, this is 2x squared plus 2 equals 0. And we want to see, does this end up giving us some additional rational roots? So that's what we need to check here for our final part, okay? Because that's going to be 2x squared plus what would be 0x, but we don't have to write that part, plus 2 equals 0. So what do we get when we try this out? Well, let's start moving some stuff around here. See where my cursor is at. So -2, -2. There, it changed to blue again for whatever reason. So 2x squared equals -2. And you can see here, x squared, we divide 2. Sorry, I didn't write that step. Divide by 2. X squared is equal to -1. So x squared equals -1. Although it's not irrational, it is an imaginary solution. Okay, when we do our square root here, we're going to end up with x is equal to plus or minus I. So those are imaginary solutions, which will not come out in the rational root theorem because they're not real. Okay, those are imaginary solutions. So our only answer here is x equals 1/2. Okay, so try your homework problems. Let me know if you have any questions. Send me an email and I will get back to you with any problems that you may have.